July 1st, 2021. We're glad that you were all able to join us this morning. If you are a frequent flyer with BCE Ag Today, you will notice that our fearless leader, Robbie Longest, is not emceeing today. So I will be doing my best to fill his shoes. Today, we're pleased to be joined by Dr. Steve Rideout, Dr. Tom Kuhar, Dr. Emmanuel Torres Quezada, and Dr. Lorena Lopez to cover cucurbit management. We thank you all for joining us. We thank our speakers for being with us this morning. Before we get started and get into these presentations, we want to cover a few items. If you have not muted yourself, please do so while the speakers are talking, just in respect of them. Feel free to type any questions that you have in the chat box. As we go through the presentations, if you have anything that comes to mind that you'd like to discuss later, go ahead and put that in the chat box, or you can just save that and we will open it up for discussion further down the line, where everybody can unmute themselves and we can speak with each other. As a reminder, these recordings will be posted on our BCE Ag Today page for review if you'd like to go back and check them out after our live session this morning. Also, they will be on our BCE Ag Today Facebook page. So with that, we appreciate again everybody being here. We can go ahead and turn it over to our speakers. I'm not exactly sure who wants to go first. I don't know if y'all discussed that or not. Steve, I know you were on first. If you'd like to take the lead, we'd be happy to hear from
you. Okay, if that works for everybody else, I can do that. Does that work for everybody?
Go for it, Steve.
Okay, all right. So I want to thank everybody for joining us here. And you know, when I agreed to do this, I didn't think I would be talking about what I'm going to be talking about today. I'm going to focus mostly on cucurbit downy mildew, just because of a development that we'll discuss. But anyway, again, Steve Rideout. I'm with Virginia Tech, vegetable pathology. And I wanted to first start off talking a little bit about viruses. We have about 3 or 4 major ones that we see in Virginia annually. And there's really no need to identify which specific virus you have. In general, they're all carried by aphids, cucumber beetles, and we have a bad problem with these in 2020. So, you know, we haven't realized any yet, but we're still early on for pumpkins, and they're really the one that they get hammered with it just because they're planted later generally. But what you generally see is you'll see a good plant growth, and then all of a sudden you'll start getting this crinkling of the leaves. So you had good plant was just growing along, they encountered a bad aphid or cucumber beetle, and you know, transmitted the virus. So at that point, you're going to have fruit that you know, is misshaping. Some of them will be aborted. You know, as they mature, their size may not be, you know, what it usually is. You see these intricate ring spotting symptoms. They may not mature at all. There are many phases to a lot of these viruses, so you'll see a lot of different symptomology with it. One thing is for sure, it will hurt. It will hurt your yield, and it'll hurt your fruit quality. So if you have not planted yet, or you're planning for like fall cucurbits, keep in mind your best defense against viruses are a good seed treatment and then a good insecticide program, which Tom and Lorena can expand upon more. So standard cucurbits, well, of course you can get untreated or organic seed, and there's really not much you can do. You just have to monitor for insects in that case. If you're conventional, your standard cucurbit seed treatment is usually going to be something like Thiram. It's a fungicide only. It's been around for a number of decades, actually. But there's a premium cucurbit seed treatment, and that's the Farmore. In cucurbits, it's FI 400. It contains 3 different fungicides and also has an extra insecticide in there as well. This is a minimal cost, so I think it's a great investment, particularly if you're planting in the fall, if you're getting ready to put pumpkins in the ground, or you want a fall crop of cucumbers or something like that, or squash. I think this investment will pay off for you. So another thing is to just scout for insects. Really keep your eyes open. We had a couple of situations last year where seed treatment wears off in about 3 or 4 weeks, roughly. We started having some insects came in, and we got some bad virus problems. These insects will also carry cucurbit bacterial wilt. So just particularly if you're still looking to plant some cucurbits, really think about the seed treatment. So the rest of the talk, we're going to discuss cucurbit downy mildew, and this is oomycete, fungal-like pathogen. It's found worldwide. It's definitely our most important disease here of cucurbits in Virginia, particularly on cucumber. But it's really problematic. So this disease doesn't overwinter in Virginia. It's what we call an obligate parasite, meaning that it has to have a host present to be able to survive. So in Virginia, we have frosts, freezing weather. We don't have cucurbits out in the field, so it really doesn't overwinter here. Where it does overwinter are places like the Gulf of Mexico, in South Florida, Central America. So every year we basically get downy mildew coming in waves on air and storms and stuff like that. So it has to come back every season. And that's the interesting part about it. And we have sentinel plots that are out. We scout for it. We send disease alerts. I just sent one out recently about cucurbit downy mildew being found in Elba, but we'll talk about that in a second. It's undergone some nomenclature and classification changes. So we used to talk about pathotypes, but now the predominant thought is that there are actually 2 clades of downy mildew, and the clade word is just basically a molecular term for strains. So the clades differ in host selectivity, movement, and also fungicide sensitivity. Symptoms of cucurbit downy mildew, you saw it on the previous slide. You'll have it'll start initially as yellow kind of angular spots. This is cucumber. So it's very characteristic on cucumber, these angular yellow spots on the top of the leaf. And if it's really, really, a dewy morning, or you just had a rainfall, you can turn over and look at the bottom of the leaf. Behind these yellow lesions, you'll see the sporulation. And it's kind of a gray, bluish color, and that's really characteristic. When you see that, you can be pretty assured that you're dealing with downy mildew. Below, this is a picture on cantaloupe. You can see the spots are a little bit different looking. So it doesn't look the same on all cucurbits, but the sporulation is really a telltale sign. If you think you have something that looks like it, there are a bunch of lookalikes out there, unfortunately. So it's not one that you can just go out and say, oh, that's downy mildew. A lot of times I have to actually put it in moist chambers and let it sporulate as well. So with that being said, just keep your eyes out for this because it can do a lot of damage. So there are 2 clades, and yes, I know I have 2 and 1 backwards, but I wanted to talk about clade 2 first, because this is the one that is more threatening to us. Clade 2 primarily infects cucumber and cantaloupe and some other cucurbit weeds. It's more heat tolerant. Generally speaking, this arrives sooner to Virginia than clade 1 does, and it has a just a propensity, probably due to mutation rate, to have more fungicide resistance. Clade 1, on the other hand, you see it mainly on squash, pumpkin, watermelon. It's less heat tolerant. It moves a little slower, so it arrives later. And there are more options when you look at fungicides. We've done a lot of research looking at, cucumber versus pumpkin versus squash and zucchini, what works and what doesn't work. And they're actually, according to hosts, some differences on what your options are. And we'll talk about how to obtain that information in a second here. So if you've seen me talk in the last 16 years, you probably, when I talked about downy mildew, I probably put this slide up. And this was the old classification. And I've kind of overlaid the new classification on that. So there were 5 pathotypes, and it was based upon, host selectivity. But now we just have kind of these 2 clades. So, but there's still some variability within these clades. So you can get a clade 1 that really doesn't infect watermelon, but will infect some other material or some other strains of clade 1 or isolates of clade 1 can infect more. So that just gives you an idea of where we were and where we're at now. As I said, we put out sentinel plots, and there are 7 different cucurbids that we put out to detect this pathogen. And from 2006 to 2019, this is basically our average first detection date. So you can see the earliest average date of detection for cucumber is August 5th. So it is, generally something that we're not concerned with until about a month from now. And you can see as you go down, it gets a little bit later. Pumpkin, September 8th. And there have been 2 years where we never saw it on pumpkin. 4 years where we never saw it on watermelon, which is even a later detection date. So again, there's variability out there. But generally speaking, we were always starting to worry about this in July. That changed this year. Unfortunately, within the last couple of weeks, this is a map showing current cucurbit downy mildew distribution. And we'll talk about how you can assess this map in a second. But I wanted to point out that these green counties here where it's been found, and I'm focusing here on the Mid-Atlantic, this is New Jersey, Maryland, and Pennsylvania. So it is July 1st. So we have an extremely early, outbreak up here to our north. We also have downy mildew to our south down here in North Carolina. I've been on the road all week. I've looked at a lot of different cucumbers and cantaloupe and have not seen downy mildew in Virginia yet. I know our agents are also helping, keeping their eyes out for it. Is it in Virginia? Probably. But it is definitely something to look out for because it's here about a month earlier than it normally is. Not all doom and gloom. Actually, the good news is we talked about the clades. So clade 2 is our cucumber and cantaloupe infector. All of these reports are on cucumber or cantaloupe. So they're likely going to be clade 2. Clade 1, which infects squash, pumpkin, watermelon, is still concentrated down here, Gulf of Mexico area, Florida. So we have not seen any movement of those up yet. So right now, the crops that we're really concerned with are primarily cucumber and cantaloupe. So what can you do? There is some host tolerance. I'm not going to call it resistance because you can still get disease on them, and you'll still need to manage it. But if you're looking at fall cucumbers, I would recommend these varieties. There are a couple of slicers and a couple of pickling cucumbers that will help you out, will slow the disease down, help you reduce fungicide sprays if you're going about it that route. Selective planting, we're kind of late into the year. I often tell people if you have something like cucumbers and you have somebody that wants a bunch of pickling cucumbers for pickling, grow those in the spring, because you can avoid the disease that way mostly. Well-drained, full sun area, scout regularly, keep your eyes open, listen for alerts from your extension agents. Like I said, when we find it nearby or when it's found in Virginia, we always send out alerts. And then the CDM, Cucurbit Downy Mildew IPM pipe website. If you go to that, you will be able to pull up the map that I just showed and a lot of other information about Cucurbit Downy Mildew. As far as fungicides, remember that preventative fungicides work better than curative, particularly on this disease. You really want to get out there and get ahead of it, because if you get behind, you know, you really, it's hard to manage, particularly on cucumber. And I say consult the Mid-Atlantic Handbook. I know we use both the Southeast and Mid-Atlantic here, but if you utilize the Mid-Atlantic Handbook, it only has the materials listed in there that we recommend. The other thing about the Mid-Atlantic Handbook, we break out the 5 big cucurbit groups. So if you're growing pumpkin and you get an alert, you know, you can go in and see what we recommend for pumpkin. Because remember, according to Clade and Host, there's some differences on how well these fungicides work. You have a lot more options for fungicides and pumpkins than you do for something in cucumber. And don't forget about other diseases. So many times we think about downy mildew and we start having things like anthracnose and alternarian watermelon, you know, Plectosporium and pumpkin. We'll have these other diseases jump up and bite us because we focus so much on downy mildew and we sprayed materials that are really, really selective against it. A lot of our downy mildew materials don't really work on a lot of our other fungal pathogens. So, you know, you need a more complete program. Use a protectant such as chlorothalonil or mancozeb, and you know, add in some other fungicides for these other diseases. So I will end there. I know, like I said, we focus mostly on downy, but you know, with this recent development, I thought that was important to talk about. There's my contact information, or work with your agent, and we can hopefully get solutions for you if you think you have downy or another disease problem. So thanks.
Thanks so much for the update, Steve. I'm sure there's going to be a few questions here at the end of the presentation today on downy. Let's go ahead and move forward. Don't know who wants to go next. We've got Dr. Tom Kuhar, Dr. Manuel Torres Pizada, and Dr. Lorena Lopez. Would any of you like to take the stage next?
Emmanuel, you can go if you want.
Thank you. Yes. Well, thank you first, everybody, for allowing me to be here. Does everybody hear me well? Do you guys hear me? Yeah?
A little bit.
All right, perfect. Let me see if I can share my screen really quick. Let's see. It's almost here. Share this one. All right, hopefully you guys can see my screen now. Well, again, my name is Emmanuel Torres. I'm a new assistant professor at the Eastern Shore Agricultural and Extension Center, Agricultural Research and Extension Center. I just started at the position not too long ago. I'll say 3-4 months. So I'm still in that process of getting used to the whole, you know, production systems of Virginia. However, I thought that for today, I might give a bit of a glance of how cucurbits are grown in different parts of the world. I had the chance of work for a while in Central America and also in South of the United States, and I've seen different systems that I think might be interested to, you know, different growers. here in the state of Virginia, either because of the quality of the that the systems provide, or the overall management that different growers around the world, have for cucurbits. Let me see if I can move this here. Here we go. Yes. So let's start with how traditionally cucurbits are grown here in the States. Again, I'm a horticulturist, so I guess I don't know if it's a good thing or not, or a bad thing, but today I'm going to just talk about cultural practices and maybe seed selections. I mean, we got experts on plant disease and plant insects, and to me, that's a more important part of the presentation. But at least we'll talk a little bit of how to grow the plant, right? In general, cucurbits are warm weather species. Germination is usually inhibited in any temperature under 60 Fahrenheit, and that's one of the main reasons why the seasons are so well established within the year. We usually try to have cucurbits in the field anywhere after the last freeze event, and we tend, at least many growers tend to at least wait a period of time before allowing their seeds to go to the field. It's just because overall the cucurbit plants, and in this specific example will be melons and cucumbers, they usually grow better in temperatures near 80 or 90 Fahrenheit. It's just something related to the actual species, right? There are different seeds that within each species that growers can have access to. Common ones are called either diploids or tetraploids. It's just a term defining how many chromosomes that particular seed might have or not. In terms of field production, the main difference between diploids and there's not many differences, between diploids and tetraploids, but whenever you get to triploids, which are the ones that growers commonly know as seedless watermelons or melons, those have a little bit of a different set of rules to be grown. The way I try to show growers to think about this is a diploid is basically has 22 chromosomes, and they don't have to remember the number. It's not important. It's just a matter of knowing that it's an even number. Tetraploids will have double that, so 44 chromosomes, again an even number. But anytime you get to a triploid, it's actually going to have an odd number of chromosomes, and that little thing right there, although the plant is going to grow, the trick is that there's not going to be an actual well-developed ovule. So and the pollen also of the plant is not going to be viable. So in order for growers to have this kind of seeds in their field, because there are advantages to them. I mean, you're basically selling a fruit that doesn't have seeds inside or minimal seeds inside. But in order for you to actually grow this, you need to mix up triploids with diploids. The reason for that is so the diploids can produce the pollen that eventually is going to get to the triploids. And although the plant is not going to produce seeds, that pollen is going to allow for the expansion of what we actually going to consume, which is the fruit, which is the actual watermelon or melon, right? So I just thought that it is important to understand that there's differences in across the species in between the different seeds that you can access to. Triploids are also a little bit harder to germinate. Again, temperature plays a big role into that. So if you're germinating in a greenhouse or a tunnel, you really want to try to get your seeds in your trays when the temperature is above 60, because if not, you're probably not going to get even diploids. The triploids are going to be even harder to germinate. If you're doing direct seedling, also is the same concept applied. I mean, the plants doesn't really, the plant will know if it is growing in the actual field or in a tray. So yeah, temperature and humidity are the two key points that you got to remember for germination. Many growers grow their plants on raised beds with or without plastic mulch. Like I said, planting dates are usually determined by the temperature of the air around in the field. Being targeting warmer weathers so the plants can actually grow. Spacing can range. Squash are planted a little bit further than what you guys see here, but for melons and cucumbers, 12 inches to 36 inches, single rows seems to be the standard. And then after that is basic management in terms of water and fertilizer, and of course pests, diseases and insects. And then days to harvest, it will usually go between 85 to 100 days for melons and 62 and 72 for cucumbers. And again, it really depends. The temperature really plays a role into this. Now, that will be roughly the standard here in the US. Here's the neat part. So although this is might be the system here, anytime if you go outside the US, the rules change. And the first one that will change is the cost of the labor. So for example, when I used to work in Central America, labor there is fairly cheaper than here in the US. And that plays a big role into what growers can and can't do in terms of the practices in the field. Just so you have an idea, in Honduras and Guatemala are the two main exporters of melons towards the US and Europe. And there's a reason for that. The first, they have the technology, and second, they have the labor is so much available that they allow themselves to do practices such as covering the whole field with this net that you guys see in these pictures just for the first 25 days, just so the plants don't have any effect of outside insect pests attacking the plants. And it's basically so they can avoid having viruses early in the season. And again, because they have the labor, it's cheaper. They have some extra money, some extra cash to actually the whole field. You're gonna see it like a white cloth for miles and miles. It's just the plants cover for the first 25 days. After they do that, well, the other thing that I wanted to mention about labor, this labor is highly trained. They have years doing it. They might do direct seedling or transplanting. And here's a short clip of how the transplanting looks. You can see how they basically, it takes seconds for them to put a plant in the field, and they will plant all this in a matter of days. Again, they have similar approaches to what we do in the States. Single road, one bed, raised bed with plastic mulch, and they just take the plants, stick it in the ground, and that's it. So again, because there's so much labor, they might not use necessarily planters or tractors. They might just have a lot of people that works there. Now, once the plants are in the field, like I was saying, the first 25 days, those plants are going to be covered by these nets. And then around 25, 30 days, because the plants are going to start producing their first flowers, the growers are going to take honeybees, and they're going to get the hives into the field, usually 1 or 2 honeybees per hectare, which is basically roughly 1 per acre. Honeybees are going to naturally start moving the pollen around flowers, and even on top of that, growers might come with an application of hormones, usually IBA, indole acid, to try to promote a better fecundation of the flowers. So they spray hormones during this period on top of all the plants. After that happens, then, in about 25 days, 30 days, you might roughly start seeing the fruits you're going to harvest. They might get to this stage. And then again, growers would get all the labor and get small plastic plaques under each of the fruits of each plant. And this is important because those fruits are going to be exported to, US and Europe. So they cannot allow the fruit to touch the ground and get damage under it. So they basically plate every single fruit in the field in all the hectares that they have. They also prune their plants to only allow 3 to 4 fruits per plant. That way the size of the fruits are fairly standard and they can ship that overseas. So again, that is a glance of how they kind of manage their system, which is a bit different of what we do here in the States. And it's just because of the access to cheap labor that they have, combined with the experience that they have to maintain the quality of the fruit that needs to go, for days in a boat to get across the sea. Another neat example of quality in cucurbits is protected agriculture. In these systems, and again, I'm using the same example of melons just because that way you can see the differences in in practices that might change, from one system to the other. Protected agriculture is also going to ensure a really good quality of the fruit, but again, it comes at a price. Both the initial investment of the structure and the labor that you're going to need to maintain the plants. Just a few misconceptions that might be out there. You can grow either, although you might be working on the protector structures, you can grow your fruits on the soil. You can grow them on soilless, and as long as you manage your water and fertilizer well enough, you shouldn't have any problems. The plants are going to be pruned. You can see how their little leaves out here they have been cut, and the growers might allow either one stem or two stems per plant. And then from there, they're going to start also pruning the fruits. You can see in this picture how all the fruits are roughly the same height. And that's because growers tend to prune um, the plant to, again, 3 to 4 fruits. And all of them are going to be fairly the same flower on each plant, either the first one or the second one. And that's why you see everything, barely almost at the same height. Then they're gonna have to trellis the plant. They have to tie them up to support system so they can grow up straight. And because the weight of the fruit is gonna be, attached only to the plant, they might also have to support the fruit, as you can see here, either with a direct string going to the connection with the stem and the fruit, or a little net like this one. Again, big thing here, although it's expensive, the quality of the fruit is kind of a key thing for this kind of growers. You can see how the net of this melon is extremely well developed. A last example, which I think is one of my favorites, is when quality gets to the string. On the other side of the world, Japan is famous for their cucurbits and the way they grow them. Although China is one of the largest, if not the largest, cucurbit producer in the world, Japan is famous for the quality of the fruit that they get. Just so you have an idea, this is a triploid watermelon that was sold for $3,000 in Japan. It comes, the reason why this happens is basically a combination of their cultural approach towards fruits and their production management. So you can see that they take really good care of the fruits. They might give it shapes. They might protect the fruits not only by hanging them and not allow them to touch anything, but also putting little hats on top of them so the excessive radiation might not hit the fruit, and there's no burns at all. And the reason for that is because in their culture, is really appreciated when you give something, when you have a gift for somebody. If you like, you can give a fruit, which is the case for these melons right here. And for them, that seems to be a highly appreciated gesture between two people. So I just think it's interesting how approaches change from high yields and volume towards extremely high quality of the fruits. And then again, the price compensates for that. In terms of the Eastern Shore, again, although I just started, many of the efforts that me and my lab are putting are towards finding ways to find a balance between quality and volume and actual yield. So this season we are actually establishing 4 trials related to cucurbits. We're going to do squash variety trial at the station, and we're going to be working with different pruning practices for melons on their protector structures. So hopefully next year I might be able to show you some data on that. If you guys have any questions, please reach out. I'm always happy to talk to anybody. Also, we have a Facebook page where you can see updates of what we do every week. If you like to follow ups, please do. And with that, I gotta say thank you.
Thank you so much, Emmanuel. That was, those insights into growing fruits from, or vegetables and fruits from around the world is eye-opening. A $3,000 melon must be quite a melon.
Yeah.
So we're going to move on. Tom or Lorena, would either of you like to go next?
Yeah, sure. I'm going to actually lead into Lorena, who will hopefully wrap it up and have some discussion with agents maybe on how we're going to facilitate this one program, but I'll go ahead and get it going.
Sounds great. Thanks, Tom.
Okay, hopefully y'all can see my slides here. Okay, I've actually got probably more seed corn maggot complaints this spring than I have in a while, and I don't know what you all have found. I guess in the chat box you can raise your hand if you were aware of any growers in your areas that might have had. I'm really curious statewide what went on. But cucurbits are one of the crops that can be hit by them. It's obviously a pest that can hit sweet corn, and there's ones that go after brassicas, the cabbage maggot, and some that hit onions. They're all very similar species of flies, very, very active in the spring. And when it's cool and wet, they're more of a problem because the flies do well in cool weather. The plants do not. The seed usually doesn't germinate, and it allows the flies time to lay their eggs hatch, and the maggots can do some nasty work here, as you see, destroying seeds, destroying seedlings. So we actually got some reports of cucurbit plants going down, stands very thin this year. And so this is one of these, like, you don't know it's going to happen until after you plant, and then you regret the fact that, you know, maybe you should have done something. What could you have done? Did I not have okay, yeah, one of the, thought I had another slide in here, and the seed treatment, and Steve mentioned it right off the bat, this farmer, I know there are neonicotinoid issues. I know there are restrictions and regulations on who can use it. And but man, if we could hang on to one use of neonicotinoids, in my mind, it would be as a seed treatment on cucurbits. Reason is the spacing. You're not talking about something that's being planted every 8 inches on thousands and thousands of acres. You're talking about, you know, wide spacing, and the value and that you get out of a neonicotinoid seed treatment on cucurbits is amazing. You would control seed corn maggot. You would not have a problem with that pest if the seed had that in there. And then you would get this 21 day protection against cucumber beetle. We've shown that pretty strong, and that is really important. That's the most critical stage of protecting the plant. And then there's the concern about honeybees, and the research has shown that, yeah, neonicotinoids have some effects on pollinators and can, but as a seed treatment in cucurbits, there's been research done where, you know, honeybee colonies that were fed neonicotinoids, nothing but neonicotinoids in their honey water at that level that they would get, that there were just no differences in those colonies. So not saying neonics are safe for bees. I'm saying that if you have a way of using them safely, it would be in like a cucurbit system where it's going down into the seed. And a lot of that's going to be long gone when you got your flowering going on. But the importance that you get out of that protection is just paramount, I believe, especially if you get heavy cucumber beetle. It is really hard to protect seedlings when cucumber beetles swarm. You can put sprays out, but it's possible the plants keep growing, and then you're going to have to put another spray out, and you're fighting a tough battle early on, and a lot of damage can can incur. That seed treatment just gives you that protection early on. So, but there's a lot of growers now that are moving away from that. There's regulatory reasons for that. And now we're left with what are those growers doing for cucumber beetles? And we had in some parts of the state already some pretty good cucumber beetle. We're seeing it right here in Blacksburg. Definite, a lot of cucumber beetles, and a lot of growers would opt for pyrethroid sprays. There's a lot of cheap ones, a lot of options, a lot of generics. And I'd say most growers are probably spraying those. The ones on the bottom are in red, and I'm going to talk about those as maybe alternatives. Probably don't want to be spraying 7 anymore. There's some other reasons. I mean, that one is very, very toxic to bees and pollinators, and also can cause some other outbreaks of other insects like spider mites and things. But let's just talk about some of these. I've mentioned this in tons of talks, the flaring of melon aphids when you start to use those pyrethroids, especially if you hit them early. You're just wiping out your natural enemies and just leaving yourself very open to these aphids getting established and becoming that. And when you have that level of aphid problems, you're going to get honeydew issues more than likely, which is going to be a problem you don't want to deal with, like a pumpkin like that late in the season. So that's our problem. I've talked about it often at our grower talks. So I want to mention these 2 insecticides. Hopefully you're familiar with them. If not, that's fine. They're relatively new. A sale's been around a little longer. The one thing they both have in common, they are like 100 times less toxic to pollinators than the other neonicotinoids, things that are in like Admire, imidacloprid, thimethoxam, and things like that. That's a huge advantage in cucurbit systems. Obviously, they're pollinator dependent. So these 2 insecticides are registered, and they are options. The next question would be, well, 2 of the questions for growers, it's the cost, but the other one is, do they work? And we have been working on that. I love this trial. Helen Dowdy ran it in 2016, but it's one that has everything. We had all the pests and we had the right products out there. We got Harvanta. We don't have a sale, but I can tell you everything that Savanto is doing is very similar data that we've gotten with a sale. And you can see the dead cucumber beetle trials are hard because the beetles are very, very active. You put your plots out and they're moving from plot to plot, flying around like crazy. Really hard to get good data if you count live beetles, but if you count live beetles and dead beetles, you can kind of get an idea of what's going on. And in this trial, you can see that there's your live beetles. Movento is not a good cucumber beetle material, but Savanto, it did the job. You see the dead beetles. Same thing with Harvanta. So those 2 products are options that are non-neonics and non-pyrethroids. So what about the aphid flaring? Well, Savanto is a knockdown, fantastic aphicide, and you can see it right there. And Harvanta also gives you aphid protection. So same thing with a sale. You're going to get it with all 3 of those options. So what if squash bugs come? These are late too after these applications, and you're actually getting a little bit of protection against squash bugs as well. So those insecticides have got a lot of boxes checked off. When growers come to you and say, well, what can I spray? What's something different? You might consider some of those costs. I'm not going to get into that. That might be something that might sway them away because they're going to be more expensive than pyrethroids, no doubt, but they're bringing a lot to the table. So I'm going to move on to one more thing, and then we're going to get into pickleworm a little bit, which I'd like to wrap up with today. And Lorena's going to take that one. My student, Sean Boyle, I think I might have saw him log in. He followed up on some work that James Wilson originally did, where we're looking at this parasitoid of squash bug eggs. It's out there. Gryon is its name. And Sean's actually taken it to where he is rearing this parasitoid at Virginia Tech and has worked with some organic growers and released the parasitoid on their farms early enough for it to get established and maybe make an impact on reducing squash bug numbers. So the goal of his project is, can you increase biological control by by releasing and inoculating fields with this parasitoid. So that's ongoing work, but it's looking promising. He's gotten higher parasitism levels where we've released the parasitoid. So that's kind of neat stuff. I'm bringing this up because now you're talking about insecticide sprays, and it's something that that's another part of his work is going to be what chemicals are not going to wipe this thing out, especially if you establish it. Okay, pickleworm, getting to the finish line here, the last one we want to talk about. There's no doubt, I don't know if you want to call it climate change. I don't know what might be the causes, but we are seeing more pickleworm problems in Virginia than I've seen in my career. And it is a southern tropical insect. So we shouldn't be seeing that many pickleworm problems. This should be a sporadic, maybe a storm that blows up late season, brings them up from Florida. But we seem to be getting it now every summer. And this is what it does. It's a small moth, lays its eggs on the blossoms, and the larvae will do their feeding. Yeah, there's some of the slides here. So we have gotten it the last 3 years. These are some of the things, some of the shots that we've gotten. These are some photos from University of Florida, but then some of them from our own lab. You see the holes that they'll do in the female blossoms, and then the frass that comes out of the holes when they tunnel into the fruit. Total loss for growers when it's getting your pumpkins, say late season. It's terrible that you've put so many inputs in, and then all of a sudden, right at the end, you're getting these things happening, and so big problem, and one that we are dealing with right now. Growers, pyrethroids do work very well. So not rolling out pyrethroids because they are a really good option, and it is late, and it might be late enough that maybe the aphids are not going to be something that you're concerned with, but there's more IPM friendly ways to go. Some of these other insecticides that really target caterpillar or lepidopteran pests, things like Coragen work very well, and will not kill natural enemies, will not kill bees. So it's another way to go. Howell and Dowdy on the Eastern Shore ran a really good trial last year. And you know, these are kind of the number, really everything that we tested, all the insecticides, Proclaim's a new one, an avermectin insecticide, they all worked. So it's not that pickleworm is hard to kill. It's hard to know that you got it. It can catch you by surprise, and that's the problem with it. And you don't want to just be spraying insecticides weekly from flowering until you're done. That's a waste, and you're going to probably have other problems if you do that. So that's going to lead into, yeah, we know the problems that you can have. Lorena, I'm going to actually let you take it over and talk about our monitoring program, which I think is going to be real important for this pest.
Sure. Hi, everyone. Let me just share my screen so we can continue. Okay. Just 1 second. Okay. Just bear with me. There you go. Can everyone see the slides?
Yes.
Yes. Okay, perfect. So just to continue, like Tom mentioned, pickleworm, it's an emerging pest here in Virginia. In the last few years, it has been reported in a lot of cucurbit crops in the States. It is a major problem in the entire southeastern of the US. In Florida, it only overwinters in Florida in this area. It had many generations per year there, and then it moved up to Georgia, South Carolina, and North Carolina, where it undergoes from 2 to 4 generations per year. And now here in Virginia, we don't know exactly. We're starting to see it, and that's why it's so important to have this monitoring program for pickleworms, to get all this information together. Also because as Tom mentioned, it's very challenging to monitor. So the adults fly at night and they don't fly to light traps or sticky traps. We don't see them during the day. There is no commercial pheromone lure to use for monitoring. They lay their eggs at night and they are tiny, so very hard to see with the naked eye, not only because they're tiny, but also because they lay their eggs on the tiny flower buds. So based on this, can we monitor pickleworm effectively? Well, the only option that we have so far is to sample flower buds from the onset of the flowering period through harvest. So the best way is to go and check the flower buds, the small developing group fruit, and the fruits during harvest. Unfortunately, we're going to lose some of the fruit to this insect, at least at the beginning of the season, while we figure it out when it's arriving to our fields. It takes around 14 days for them to develop since they hatch from the egg through adult. And during that time, the best time to apply pesticides is when they are hatching from the eggs. It takes about 4 days for them to hatch, since they lay their eggs, to hatch into first instars. And sometimes they move from bud to bud or in the plant. So that's the moment where we want to monitor, where we want to catch them and apply pesticides to kill them. Also, what crops do we need to sample? Well, they infest pretty much all cucurbids in the genus Cucurbita. So they love summer squash. All summer squash basically are infected by them. Some winter squash are also infested. We haven't found any pickleworm in pumpkins or winter squash so far here in Virginia, but there are reports of infestations in other states. And also they go for melons and watermelons, but their preferred host is summer squash. Also, they seem to really like going after yellow zucchini or yellow summer squash. And we also have field observations from 2019 that shows the potential of using yellow squash as a trap crop or sentinel plants that you could have around your field, hopefully not too close to your other squash, but you have around, and then you can constantly monitor those plants to identify the arrival of this pest on your area and treat accordingly. So this is one technique that we could use for monitoring that could help identify the best moment to scout and to treat. And all this information is very important, and hopefully we'll be able to do this kind of monitoring for several years, where you could check your crop or your sentinel plants and actually let extension agents or let us know if you found them. This is like the start and the preliminary things, the base data that we need for bigger projects that we hopefully will start this year or next year, where we're going to evaluate different monitoring techniques to improve this monitoring program over time, and also hopefully to get some pest management tools, some cultural practices, and of course always new pesticide products that help us mitigate the damage that these pests cause in cucurbids. So please let us know, for the growers, please let the closest extension agent know if you find this pickleworm on your fields, especially now that fall squash season is coming. And also the extension agents, please let me know. Here's my contact information. If you find this, we want to know where this pickleworms is found in the state, and record all this for future collaborations in projects, and also to help you work around this. this pest. And with this, I just want to say thank you, and we're happy to answer your questions.
All right, thank you, Lorena and Tom. As well as the rest of our speakers, thanks for coming out today and sharing with us. At this point, we're going to go ahead and open it up for questions. You can either type your questions in the chat box, or at this time, you have the option to unmute yourself and ask those questions or start a discussion with the group. So this will be the time to do that. I do see one question in the chat box that Tom has already answered from Ed Olson. Seed corn maggots, do they overwinter in Virginia and affect seeds? Tom replied, yes, seed corn maggots overwinter in Virginia. Adults emerge in early spring.
Well, while we're waiting for any questions for all the extension agents out there, you know, we want to write this later, you know, when the annual report time comes around Christmas time, and we're all like, oh geez, EFARS. We want to write a nice one, you know, the number of agents involved in this, the number of growers. So definitely keep track of your numbers that you disseminated out to. I know each of you have Twitters, or you know, you've got some newsletters or alerts that you send out. That's something that Lorena will try to compile, which is like the number of growers that we communicate with. So this is an easy sampling strategy. I mean, we're really just looking for it and letting everyone know where it's being found. And but I think we could have a big impact. So clearly let her know all that information, that, you know, yeah, please, I'm sending it out to, you know, 30 growers in my county or something like that. That information will be pretty valuable as well.
Tom, it looks like we've got a question for either you or Lorraine in the chat box. So are we looking specifically at pickleworm and summer squash because they'd be the first crop to be affected?
Yeah, I mean, Lorena, you can take that. I don't know that that's going to be the first crop that's going to be affected. And I don't think it's, you know, if you don't have summer squash ready, you don't have any fruit for some reason, but you do have pickles or something and cucumbers, and you see it, then clearly that information is valuable. You didn't have to stick with summer squash. That was just a crop that, you know, Sean Boyle, who's, I think he might still be on here as well. And I've seen it on the first is our summer squash. Now that might be because we grow a lot of yellow summer squash, and the timing might be right. But I also think that there's a lot of evidence, Lorena, you may know from some of your work in Florida, but I think that's a good crop that just produces fruit at the right time and goes from July into the fall. So
Yeah, I agree with Tom. They're just going to jump into any kind of cucurbit that you have. It depends on where you are, and if you have melons, or if you have watermelons, but you don't have summer squash, that you might find them there too. It's just, as Tom said, that sometimes it's easier or a little bit faster to find them in squash, but it's not necessarily the first one that they're going to infest.
All right, if anybody else has questions, you can feel free to go ahead and unmute yourself and ask those now, or type them in the chat box. We're gonna take a couple moments here just to see if anything else trickles in. Well, all right, not hearing anything else. We once again want to thank all of our speakers for coming out today and sharing all this great information with us, as well as all of our participants out in the audience. Thank you for joining us. This session, as well as all of our VCE Ag Today sessions, have been recorded and they are available on YouTube on a playlist called VCE Ag Today. You can find all of those there as well as on our Facebook page. Our next VCE Ag Today meeting will be held on July 15. On the 15th, the topic of discussion is going to be the VDAX pesticide disposal program led by Jeff Rogers with VDAX. He's going to go over the upcoming disposal program, give you the ins and outs of how to participate, what you need to do in order to be a part of that. As always, want to thank the group of agents and interns that make this possible. Stephanie Romelchek, Robbie Longest, Laura Maxine, Frank Long, as well as our interns, Claire Talamy and Sarah Hallam. Finally, you'll see scrolling along your screen a link for evaluation. I think Laura has also put it in the chat box. Please, if you have the time, take 30 seconds to take that evaluation. It helps us identify topics that you would like to hear in the future to give us a better idea of where we can take this program as we move forward. With that, we thank everyone for attending today. Thank you so much to all of our speakers for being here with us and sharing. Thank you to our participants for coming and listening. We look forward to seeing you again on July 15th, and we hope you have a great day.